Hello everyone, my name is Ahmad Alsaleem, and today I'm going to present to you applying ability-based design principles to adaptive outdoor activities. This work has been done at the University of Utah with other collaborators that you can find their name on the slide. Ability-based design, or ABD, is a design framework for creating accessible systems. ABD focuses on the user's abilities rather than inability. ABD shifts the burden on the system to adapt to the user's needs and their abilities, rather than making the user conform and adapt to the system requirements. ABD consists of 7 principles. 3 are required and 4 are optional. Ability and accountability focuses on making the design of the system focused on user's ability and centered on what the user can do. Availability focuses on making the system affordable and available. Adaptation focused on making the interfaces adaptable to the user's ability. Transparency gives the user the power to do any needed changes to these adaptations. Performance focus on making the system monitors and sense users' performance and adapt to the user's level of performance. Context focus in making the system utilize the user's situation or context to accommodate for their effect on the user's ability. For more details about these principles, please refer to the ability-based design paper. Ability-based design has been explored in screen-based systems. Examples: Supple, a system that automatically generated optimized user interfaces based on the user's ability and performance. A second example is VoiceDraw, an application that enabled the mouse cursor to be controlled by a human voice. VoiceDraw adapts to the user ability, producing vowels. Two great examples that show the great potential of ABD, but the two examples are used in the context of screen-based systems. In our work, we want to study and answer how applicable to transfer and apply ability-based design principles into outdoor activities context. To answer this question, we explore the principles of ABD in two adaptive outdoor experiences, Tetra-Sail and Tetra-Ski. Tetra-Sail is an adaptive sailing experience that allows individual Tetraplegia to sail collaboratively with an instructor. Tetra-Ski is an adaptive skiing experience that allows individual Tetraplegia to ski collaboratively with an instructor. Both experiences went through multiple iteration for over the 5 years. In the next slide, we'll show you a video of those experiences running in the wild. Both experiences targeted individual tetraplegia as users. Individual tetraplegia have different abilities that require special consideration in designing outdoor experiences for them. A designer should accommodate for their wide range of their physical abilities, as some user would have total loss of all of their 4 limbs and torso. In our case, to accommodate to all our users' ability, we use 2 input systems, a joystick system and a sip and puff system. The joysticks function like a traditional wheelchair or any gaming joystick by having 4 directions of the movement. On the other side, and for higher level injury tetraplegic user, we have a sip and puff option. Sip and puff is a mouth control system that detects the changes in air pressure. So a user inhaling from the sip and puff tube will detect as a sip command. Similarly, a user exhaling air into tube will be detected as a puff command. After designing and deploying experiences for over than 5 years, we learned that making the system adapt to our user needs and abilities is a very difficult task. As we have a wide range of abilities, And these experiences run in a very dynamic environment that will be hard to predict on how should the system adapt to the user's abilities while ensuring safety. To solve these challenges, we resulted in shared control. Shared control is a collaborative control scheme between two parties trying to control the same activity. In both experiences, we have an instructor, we refer to him as control partner, that uses a remote control to help the user to control the experience and adapts to the user's needs. In shared control, the main user would request any necessary changes in the system to match his or her ability best in terms of adaptation, transparency, and performance to the control partner. In return, the control partner will adjust the system when it's feasible to accommodate for the main user requests. So the control partner is acting as a middle point between the system and the main user, trying to figure out the right configuration that suits the main user abilities and requests and still obey the requirements of the environment. Thinking about ABD in terms of screen-based system, a design might not be restricted by many constraints to apply ABD principles. For us, even having shared control helping us applying ABD to our sports, we still end up in a situation where we could not accommodate for all of our users' requests. For example, Tetra-Ski asking for more speed. In such situation, given the user more speed will pose a danger to the safety of the user and the control partner. So a control partner need to weigh in what is acceptable or not from the user's requests. So basically, it's not a direct application of those principles when it comes to outdoor activities. Before diving into other constraints, I want to first introduce a new terminology, flow. Flow presents this concept of an experience level of challenge needs to be matching the user ability to provide the user with enjoyable experience. This is very important for our sports as for all our sports activity. For all sport activity needs to provide the appropriate level of challenge for the user. Now back to what we learned, we found that applying ABD principles in outdoor context is sometimes restricted by other things like flow, risk, and environment, based on our deployment and observation and experiences. So a designer needs to take into consideration these factors before making any modification or adjustment to the system. For more details about these factors and how they influence ABD, please refer to our paper for more details. ABD provides a well-defined design scope through their principles. Reflecting our work in general, ABD provides designer with a set of well-defined design components through their principles that can guide the design process. Such guidance is very important for us as it keeps us focused on what needs to be changing next and why, rather than targeting random goals to achieve accessible, usable system experiences. In our first stage and due to our limited resources, we prioritized adaptation of other principles, as we wanted to create an accessible experience to understand the user's reaction and feedback by bringing them out to try our activities. After our first deployment, we found many situational impairments that we were not aware of. For example, Tetra-Ski's joystick user inability to control the joystick due to the pulling effect from the gravity and the speed of turning of the device. This made us go back to design phase again. In the second stage, after gathering new data about user experiences, we ended up rearranging the prioritization for design goals based on our schedules, resources available at the time. For example, for Tetra-Ski's second stage, context jumped to be first priority over adaptation, as context affected our user ability to safely control Tetra-Ski, as we learned from the first deployment. Similarly, for Tetra-Sail, we pushed performance to higher priority as users wanted more speed and control option of the experience. In conclusion, shared control made it possible for us to apply a build-based design principle to outdoor activities, and applying a build-based design principles in an iterative process. Thank you for watching this video.